Okay, so good morning, everybody. And today we're going to do circuit analysis. I have to make this video because it's kind of a little complex, but for those of you who need it in college, it's very important you know how to analyze a circuit. And the whole thing goes back to understanding parallel and series circuit. So just want to make sure that we have two triangles. One is power, so that's your power, just like any other power we learned so far. And the unit for power is watts. And then this one is voltage and current. The other formula we learned was the Ohm's law, which basically voltage and current. So we kind of Ohm's law says the resistance is equal to V divided by I. And here power says it's equal to voltage multiplied by current. Okay. So now I basically have to erase everything because I will leave the solutions for you. I just want to explain it to you so it's easy to understand, but it won't let me move up without erasing. So two things we want to learn, series and parallel circuit. So in a series circuit, which you see here, there's only one direction for the current to move. There's only one path, one way. So in a series circuit, this is what happens. The total resistance of my loads basically is equal to the resistance of the source. So when we use the word T in here, when we use T, this is really the total, stands for total, but it's actually talking about my battery or source. So if I have 100 volts in here, and here I have my resistance R1 equal to that, and there's no other resistance, that's the only resistance, so therefore the total resistance is equal to 250. So that's when I have only one, right? Now, in a series circuit, the current of the source is equal to the current everywhere else. So if I had something here and here and here, all the currents are the same. The problem is I don't have anything else to solve. But what I have is 100 volts. So my source, my battery, whatever you want to call it, your outlet, here has 100 volts. You have to have two known before you can calculate an unknown. So here, therefore, my current is going to be equal to V divided by R. That's why we had to learn Ohm's law. So 100 divided by 250. And since it doesn't fit in here, I'm just going to put in here and it will be 1/4 100 divided by 250.4. I have to calculate it to make sure. So 100 divided by 250.4. So yes, so 0.4 amps is the current of the source. That's the current that passes through here. But because it's a series circuit, you get the same current everywhere. So this becomes 0.4. Now, what's going to happen? power here is equal to V, right? V times I. So now I have my current. Now I have my power, so it's going to be equal to 100 times 0.4. So the answer is going to be 40 watts. Here, what's my voltage? I'm going to use Ohm's law. V is equal to IR, right? I times R. That's why you have to have your formula sheet to make sure you use it. So V is equal I times R, so 0.4 multiplied by 250 is equal to 100 volts, right? So it makes sense. If I have 100 volts here and I only have one load, that means I will have the same voltage. And what it means, voltage, it means when the electrons are coming, and if they carry 100 joules of energy right here, then when they pass the light bulb, they're going to drop that 100 joules at one light bulb. So they gain energy here, they lose energy. So the potential difference, the word, it's actually coming from the fact that electrons here, they have to drop their voltage right at this light bulb and then move on back to the source, gain again energy and come back to the light bulb, drop it, and then so because there's only one light bulb, obviously the amount of drop is equal to the source. So if each electron is getting 100, just imagine $100, therefore the drop is $100. The story is completely different when I have 2, 3 light bulbs. The drop will be very different. So now power here is equal to V times I, so 100 times 0.4. And so naturally you get 40 watts. I will just put a nice version of this for you. So I hope this makes sense. This is only when I have one load and one device. Unfortunately, I have to erase everything again before I move on, because otherwise the screen moves and the words don't. So now let's go over here. These are called Kirchhoff's law. The law says that in any series circuit, the total resistance of the source is equal to all these resistances add together in a series circuit. So R total will be equal to R1 plus R2 plus R3. So that means 100 plus 167 plus 400. The total becomes 667. So this is how I calculate the R total. I simply add all of this together. So, okay, that's good. Now the voltage is 100. I don't know the voltages here. It's not going to be like the first question. But I have the voltage of the source. So anytime you do circuit analysis, in one point you have to have two knowns. Here I only have one. Here I have one. Here I have one. Here I have two. So the next thing I'm going to calculate is I. And I is equal to V divided by R. So 100 divided by 667. And the answer is going to be 0.15 amps. God, it's so hard to write with mouse. Okay. Now, the second law says the current of the source is equal to the current everywhere. So I1 is going to be 0.15. I2 is going to be 0.15. And I3 is going to be 0.15. So now I have 2 everywhere. And I'm going to use Ohm's law and the power formula to calculate the rest. So here, V1 is going to be 60 volts. How? V is going to be equal to I R. That means 400 multiplied by 0.15, you get 60 volts. Same thing here. R2 times I2, I get V2. And V2 is going to be 25 volts. I3 times R3 is going to be 15 volts. Now, the next law here says voltage of the source is equal to V1 plus V2 plus V3. So 100 is going to be equal to 60 plus 25 plus 15. Correct. So that means I did everything correctly. If you're adding V1 plus V2 and V3 and you're not getting 100, you've done something wrong. So now I'm going to do power. Power is voltage times current. So the first one is going to be 15 watts. Next one, multiply V times I, 2.2 watts. P2 is going to be 3.75 watts. And P1 is going to be 9 watts. So you can see here that 9 plus 375 plus 2.25 is equal to, so that's the other law. The total of power is equal to P1 plus P2 plus 3. So these two are similar, okay? So the only thing in a series circuit, stays the same everywhere and it's not adding or changing is the current. Okay, so I'm going to erase that. Okay, now we're going to look at a parallel circuit. So in a parallel circuit, things are a little different. How? The resistance has this funny formula. So 1 over total resistance is equal to 1 over R1 plus 1 over R2, that's plus 1. Here, fractions can get really ugly, so you need to get used to calculating this. What I do, I put this stuff in my calculator, and at the end, I inverse it. That's the easiest way to do this. If you're not, crazy about kind of fractions, that's what you can do. So now this is called a parallel circuit because it has 3 different paths. Anything more than one path, it's a parallel circuit. In a parallel circuit, the voltage drop is the same. So if I'm losing 100, if I'm gaining 100 volts of energy, these electrons, some will go here. So the drop would be 100. Some will go here, the drop will be 100. Some will go here, and the drop will be 100. So all of these light bulbs will have the same voltage. So if this is 100, this will be 100, and this will be 100, and this will be 100. Similar. So now you can see I have 2 known for each one of them. So I'm going to find the I. So here I2 is going to be V divided by R. It's going to be 0.6 amps. I3 is going to be I3 is going to be 1 amp and 1 0, so it looks professional. I1 is going to be 0.25 amps. So now, in a parallel circuit, unlike the series, the I's have to add up. Why? Because some electrons will go here, some electrons go here, some electrons go, and the same electrons can't go in 2 places. So what is the definition of current? Number of electrons per second. So here, in order for me to find my I total, I have to add 0.6 amps, 1 amps, and 0.25. So now if I add all of them, I will get 1.85 amps. So how do I find the R total? We have to go through this formula. So 1 over R total will be equal to 1 over 167 plus 1 over 100 plus 1 over 400. So that's basically, it's the crazy thing. And what I'm going to do, I'm going to add them like that. I'm just going to put for 1 divided by 1.1 divided by 167. So here you say 1 over R total is equal to 0.00598. Put as many digits you can, plus 1 over 100 is 0.01, and 1 over 400 is 0.0025. So I'm just going to add all of that. Plus 0.01 plus 0.00598 plus 0.01 plus 0.0025. So the answer is going to be 0.01848. But you have to pay attention. This is 1 over R total. So in order for me to find R total, I have to inverse that. So 1 divided by 0.01848. And if I do that, I hope I calculated right. So 1 divided by 0.01848. So it comes approximately to 54 ohms. So that's what I put here. This is the most important part, is how to calculate it. This is how I do it. I simply calculate this, calculate that, add them all up, and at the end, I inverse it. So I get the right answer. That's the easiest way if you don't like fractions. If you love fractions, which I don't, you can more than welcome to do it. So now power again, V times I. So the answer is 185 watts. Power to here, 60 watts. 125. Again, power is V times I. And this one is 100 watts. Now, in a parallel circuit, again, power is P1 plus P2 plus P3. So we add all of these powers, they end up being my total power. So I will post this handout for you, and it will have the solutions of the paper. The page 3, the last page, you know, you practice one page, and the last page, I want you to try it. And if you can, just take a picture of it and send it to me. That way I can tell whether you're doing it. If not, just try the quizzes, that's fine. I will make sure I put enough circuit solving for you. But hopefully that video explains enough for you to know what's going on. Thank you.